This is Excel Funda, and today we are going to break down a really cool problem from Leetcode, that is problem number 273. These are two English words conversion. So this problem asks us to take any number from 0 to up to 2 billions, and we have to turn it into an English word representation. So let's go and understand the question. Question is saying that we have given this problem, and the problem is saying that we have to convert a non-negative integer into words, right? Let's suppose this num is given and we have to convert into the English word. What does it mean? So example 1 is saying that we have given num is 1 2 3 and we have to convert into 123. Another example is 1 2 3 4 5. This will become what? 12,345. If we talk about this, it will become what? 1,234,567, right? Like that. And this is the constant we have given. How do we go about converting a number like this, right, into a plain English word like this, right? So there are some strategy, right, that we need to do, right? Before that, we should understand what does the Leetcode problem, this one, is asking to us. What is our end goal to do that, right? So our end goal is to take a number. If we are taking any number between 0 to 2 billions, we have to return it into an English alphabet, and that we have to represent. So let's suppose if we have 1 to 3, we will write 123. If we have 1 to 3 4 5, we will write 12,345. If we have 1 2 3 4 5 6 7, that is 1,244,567. Like that we have to do, right? So let's first break down our strategy. Like first we will do group the number by thousands, means billions, millions, thousands and the rest. Then we have to process each chunks of 3 digits one at a time, and for each chunks what we need to do, we have to handle hundreds, we have to handle tens and ones, and then we have to deal with numbers, right? Tens, 11s, those things we have to do, right, till the 19, right? Then we have to stitch everything together, and we have to clean up our extra spaces, and we have to return the final answer, right? Means first of all, the step should be group the number by thousands, like billion, million, million, thousands, like that. Then we have to process each chunk of 3 digits one at a time. So for example, one chunks in the in that we have to handle hundreds, 100, 100, and then we have to handle tens and the ones, right? Then we have to deal with the numbers like 11, 12, 19. Those numbers we have to segregate. After that, we have to stitch everything together and we have to return it, right? So how we are going to implement it? If we will have number from 1 to 19, think about that. Any number begins from, let's suppose, 1 to 19, before 20, right? So the words for numbers from 1 to 19 we have to define, right? So let's suppose we have some numbers which is less than 20, right? Then what we need to do? First of all, we will define some numbers which is between 1 to 19, and then we'll say numbers will be from what? 1 to 19 will be all those in English alphabets, right? So we'll define what? Below 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, right? Means these values we have to map into one variable in the below 20, and that is called our strings of array. So this string of array below 20 will keep like the blank 1 to 19, right? Then after 1 to 19, what are the numbers are there, right? All the numbers having a 0, right? Let's suppose the tens, that we'll call as a tens, that contains a 0. Not about the 10. 10 is different, tens are different. So tens like 20, 30. So tens will be the number that contains 0. Means first of all, we'll take 1 to 19, right? And we have to define like this. Another will take all the words that contains in the tens, right? That contains 0. Like 20, 30, 40, 50, 60, 70, 80, 90, right? Like that, we have to go from 20 to 90, right? Means that will call tens that contains 0. in the last, right? In the last digit, means that will come thousands group. So how you define thousands group? So further we'll take thousands, millions and billions. So we have to group the, you can say, these type of groups we have to implement first, right? This is our basic needs that we have to do before the conversion, right? We have to initialize these variables before writing the code. Once these three are done, right? So in the main function, let's suppose we have not talked about the zero. If you go back and if you say there is nothing, no place is the zero, right? So first of all, what you should do? You should think about the base case, right? Not we can say base case, but the edge cases, right? So edge cases we will take if num equal to 0. If the number we are putting in this function is 0, we directly say return 0. We will not do anything, we'll return 0. Then you have to construct what? String. So to construct a string, we will not take the string data type. In Java, there is a string builder, right? String builder is the string constant pool is not blocking him to append the data, and not it is updating multiple times into the not constructing multiple times the new string object into the string, right? And so that we should optimize our code, and to optimize that we should use string builder. So if we will append anything in the string, we will not create a new object into the heap, right? So, or a string constant pool you can say. Okay, so we will take a string builder that is called result, right? Like this, string builder result equal to new string builder. Now this string builder that is called result, if we do result dot to string, we will return the answer that is required for string. If we will do result dot to string, you will convert into the string. But before returning it, you should have some data here, right? So now it is completely blank, nothing is there in this, right? It is null, right? You have just initialized it. So now let's understand how we are going to implement. First, initialize a variable int I equal to 0. Then while num is greater than 0, because 0 we have already checked, right, at line number 2. Now we'll define while num is greater than 0. If it is 0, return 0. But if nums is greater than 0, then we need to implement. So what I have told you, first of all, we'll take 3 digits chunks, right? So to do that, what we need to do? First define int chunk, right? And divide by 1000. So if you divide by 1000, you will get 3 digit first, right? And to get the 3 digits, you have to do what? You have to take the mod, not divide. You can take the mod, right? So if you take the mod, you will get the 3 digits, right? So you define, you take the chunks of 3 digits, and then what you need to do? You have to check if the modulus, if you will take in the mod of 1000, this num should not give 0. If it is giving 0, means we are done. All the elements we have already processed, right? So we will check a chunk is not 0. If chunk is 0, means this mod is giving 0, means all the elements is finished now, right? Then we'll process the chunk and we will add the 1000 group, right? 1000 group is where 1000, you remember I'm talking about these thousands group. So these 1000 groups having what? Thousands, million, billions, right? So for that, what we will do? We'll check if chunk is not equal to 0, we'll process the chunk and we'll add the 1000 group. How? So to process the chunk and to add the 1000 group, what we need to do? We will write result, because this is the result that we have to do, right? So in the result, we will insert, means we are appending some value. We will do what? Helper chunk. So this is a helper function, right? I'll show you the helper function later. Just think, we'll pass the helper function and we'll get the English letter, English alphabet, right? And then thousands at I. So at I, there is thousands at I, right? It will give you the result, right? At the you need 1000, million, billion, what is required, that we will get. Means helper function will give you, let's suppose 1000 billion, 10,000 billion, like that we will get, right? So this helper function will give you the English letter, and this will give you the thousands group, right? From the thousands group, you will get the element. And then you will add into the result. Now, we'll divide the num by thousands so that we will segregate each nums in the three chunks, right? So this starting 3 digits we have already from the start list of 1, 2, 3, 4, 5, 7, right? 6, 7, right? So starting 1, 2, 3 we have processed. So 1, 2, 3 we have processed. So if nums having 1, 2, 3, 4, 5, 6, 7, right? We have processed the 3 digits, right? And so 3 digit we have taken the chunk, and this chunk we have passed in the helper and the thousands. So you will get, that is called in the million or billion, that will come here and you will get the result. Now after the 3 digit, if we will divide that, so starting 3 digit we will discard it, right? So we will discard that, okay? And then we'll do I plus plus. So n, this num is 1, 2, 3, 4, 5, 6, 7, right? We will break these nums, right, into 3 chunks. How will define the 3 chunks? So the first chunks, let's suppose will come 5, 6, 7. Another will come 2, 3, 4. Then another, in the last it will get what, 1. So these are the prerequisites that you need to do, right? Understand nums to the words, right? First of all, let's suppose we are going to take here 1, 2, 3, 4, 5, 6, 7. Okay. Then we want to convert this number into English alphabet, right? So it should come what, you can say 1 billion, it will come, and then 230, 234 thousands, and then 567. Okay, that we need to convert. Understand? It's not equal to 0, then we'll return the 0. If it is, let's suppose we'll pass here 0, then we have to return 0. But here we are passing what, 1, 2, 3, 4, 5, 6, 7. Then we have to construct our string builder. We have to convert all the data integer into string, and then finally we'll take a result or to a string, and we'll do trim to remove extra spaces at the end, and we'll return it, right? Let's suppose we have this number 1, 2, 3, 4, 5, 6, 7, right? So we will break the number into 3 group of 3 digits. How? See, we can break like this also, right? We are dividing by thousands, okay? And then we are taking also mod. So mod, we will take the mod of the number by 1000, right? We will take the modulus, right? You will have the chunks. So chunks means the group. There will be 3 group. In the first group, let's suppose if we'll take the mod, what will come? Let's suppose the number will come 5, 6, 7, right? Let's suppose number will come 5, 6, 7. In the second chunk, the number is coming what? 2, 3, 4. In the third chunks, it is coming 1, right? Let's suppose the first, from here, we will get how many chunks? We will get 2 things. The first chunk, let's suppose, chunk 1 will contain 5, 6, 7. You pause and you understand. Chunk 2, you will have what? Chunk 2, you can say. Chunk 2, let me copy this. And chunk 2 will have what? 2, 3, 4, right? 2, 3, 4. Okay. And chunk 1 will have 1, right? Sorry, chunk 3 will have 1. Chunk 3. So chunk 1 will get here, here, here. Okay. So all those chunks you will get. Now check, it should not be should be 0. So till it is not 0, we will call this one. Okay. Means we'll process the chunk and we'll add the thousands group. Okay. So let's suppose first we will process with the chunk 1. So in the chunk 1 we have 5, 6, 7, right? So 5, 6, 7 is greater than thousands, right? Greater than thousands. So if you come here, you will see here, right? It means if we'll call here, in the first chunk will come what? 5, 6, 7, right? Where it will go? It will not go here. It will not go here. Not even here. Means it will go greater than what? 100. Means at here, nums by 100. 5 by divide by 100. What you will get? 5, right? So after that, what we have to add? 100. So you will get what? 500. What will get? 500. Now remaining is what? 67. Since 67 is greater than equal to 20, so you will come to this one, right? So you have already added 500. Now you will get what? Helper function you again will divide. You will take the mode and you will call it, right? Again you will calling the helper. So it will go back here. Now it is coming 67. 67 will come in this loop, right? So tens, 67 by 10, it will come out 6. So you will go at the 6. 0, 1, 2, 3, 4, 5, 6. You will get 60. So you will get 60. 560, right? Now again we'll come to here, right? Sorry, not here. Here. 67 by 67 more 10. What will come? 7. Now it is less than 20. You will go here because this is helper function. You will go again here in this one. So recursively we'll go till it is not coming equal to 0, right? So we'll come here. You will get at 7. At 7 what is there? At 7 we have 7 that you will get. Again it will come here. No, it will not come because that is we are not calling again, right? The helper function we are not call because we are not doing anything. We'll just take a space, right? So what you will get here till the final, if you call the result, now in the result what you will have? You will have 567, right? Now we'll process the next chunk. To next chunk you will do this, you will come across here, and now what you have in the second chunk? You have this one. Similarly you will process this. What you will get? 234, right? It means you will get 234,000, right? Next time in the next chunk you will get at chunk 1, you will traverse it and you will get what? 1 million, right? Like this. I hope you understand, right? So you will append everything where? At this position, at this this line, right? You will have everything appended, means 1,234,000 and the 567 you will add here, right? And you will get 1,234,000, right? If you not are aware with this 234, how you will get? So in the first chunk, because see, you have to keep adding, right? Insert, right? You have to keep inserting. So it will go in the reverse order. Let's suppose if you are adding onto the stack, it will go down. Which is coming? The last. Which is going the first, it will come the last, right? So in the last, who will go here? At here. So that is why we have to take, right, 1 million. Then the thousands, and then in the number 100, right? Like this. You understand, right? So if you'll come from if you'll go for the 234, you will process same, right? 234 will come here. I have not explained, so let me tell you. So 234 will come. So at when the 234 will be there, right? It is greater than what? 100. You will come here. Means you will get 200. Then we have 34. Then we'll got 34. We'll get from here 30, and then we'll get from 4, 34, right? Right? It less than 100, so you will get here. 200 you will get from here. 34 you will 30 from get hand here, and 4 you will get from here, right? Then you will add it, right? Everything you will get. Now you have to, when you will get the one chunk, last chunk 3, let's suppose here. So you will get what? At this position, chunks at 1. So chunks at 1 you will get from here. We will come here, you will get 1, and at this position you have some I, right? What is I? You are also doing plus plus, right? So first chunk came, second chunk. Now we are getting what? Value at chunk 3. It will become what? 3. So what you have at 3? Check here. What you have? 0, 1, 2. So when chunk 1 was there, you was here. When chunk 2, you was here. When chunk 3, you was here. That is why you got what? 1 million. 1 million 234,000 and 567 nothing. Understand? I hope you understand. Okay, let me know in the comment box you understand the problem. Okay, problem statement. Now you have to write time complexity, space complexity in the comment box. Thank you for watching this video. If you are new at this channel, and please support by liking and subscribing this channel.